Hey guys, so with me I have what was called a round bottom flask or a ball flask, and I have some aluminum foil wrapped around it. And what I'm going to go ahead and do is I'm going to drop something into this bottle, and we're just going to go ahead and see what happens. So I'm going to move this down right here, and I'm going to keep this out of the frame so you don't see it. I'm going to drop a little bit in. Let's go ahead, let's see what happens. Lots of smoke coming out of this. A lot of smoke. And as I'm feeling this, the flask is getting really, really warm. Okay? And what I'm kind of feeling with that smoke that was coming out, it's kind of making my fingers wet. A little bit wet. So I'm going to set this aside for now. Okay? I'm going to tell you what was happening here. Okay? So in this flask right here, it might be hard for you to tell, but I'm going to go ahead, I'm going to take the wrapping off. I think. I'll show you the bottom real quick. This is really frustrating. All right, here we go. All right, so I have this free right here. And in this bottle, you can see there's like some purple stuff. It looks black on the bottom. You could see the steam kind of on the inside of that flask there. What I actually put in here, though, was actually hydrogen peroxide. All right, and now it looks black. Okay, and it's really warm when I touch it. So before I can explain how this worked, I have to go up to the board real quick and say a few things about hydrogen peroxide. Okay. So I'm going to make my way over there. It's a really far trip. Just take a few steps. Okay. So what I had was in that bottle, I had hydrogen peroxide. Okay. And we might know at this point that the chemical formula for hydrogen peroxide is H2O2. You might think, man, that sounds really familiar, right? Well, water is H2O. Hydrogen peroxide is water with an extra oxygen atom added onto it, okay? That's going to be really important because what hydrogen peroxide naturally does over time, okay, we don't have to do anything to it. We could just let hydrogen peroxide sit in a bottle, and what's going to naturally happen over time is it's going to turn into H2O and oxygen. So naturally, when hydrogen peroxide has two oxygen atoms, naturally one of those oxygen atoms is going to break free, and hydrogen peroxide is just going to turn into water and oxygen. Okay, and that takes kind of a while to happen. But what we would do is we would call this a decomposition reaction. Okay, right up here when it turns into water and oxygen, because that molecule, that compound of H2O2, it's decomposing into water and oxygen. Okay, and that naturally happens. What I did here today was I had a bottle, okay, and I filled it with hydrogen peroxide. I'm going to go ahead and do that. And this hydrogen peroxide is a little bit stronger than the kind you would normally get at the store. This is called 20 volume. I actually had to walk into a beauty store to get it, believe it or not. When I walked in there, they're like, how does a person with a beard that bad know where a beauty store happens to be located? I took offense to that. I'm just kidding, they didn't say that. All right, so I had some spill. So in this bottle, I have hydrogen peroxide right in here. And we can't see anything happening right now, but gradually over time as this is turning into water, like I said, okay? It's turning into water and oxygen. We're going to go ahead and add something called a catalyst, okay, to speed this natural chemical reaction up. And you might remember back to when we made copper, okay? We had copper sulfate and we put aluminum in it, and then we were expecting it to make just, like copper, right? And it was taking a super long time, so what we did was we added salt to speed up that reaction. That's what we're doing here, okay? We're using something called potassium permanganate to speed up this reaction. And yeah, kind of nasty stuff. We don't really want to be messing around with this stuff. We want to be careful with it. But what the potassium permanganate is going to do is it serves as a catalyst, okay? So it's going to speed up the decomposition of hydrogen peroxide. It's going to cause those extra oxygens to break free from the H2O. And when I do this, okay, we're going to notice quite a change. So I'm going to set this right. Actually, I'll probably set it down. And you guys can see what's happening as I drop this in, okay? Immediately we see a lot of smoke. You can see some bubbling going on down there. And we have water vapor coming out, okay? That smoke is just water vapor. And to give you an idea of how hot this is, it's not just oxygen leaving. Since the water in there is so hot, it's really starting to boil. And we're kind of like how you would if you were to cook spaghetti and you heat up the water, you see the steam coming out. That's how hot this reaction is. Okay, that's how warm it is. We would call this an exothermic reaction because it's super warm. It releases a lot of heat. And you can see the steam on the outside here. And kind of looks a little bit like, I guess, Coca-Cola, Coke or Diet Coke or any kind of dark drink, dark pop. But starting to get a little bit clearer now, so you can kind of see what we got there. And you can see the bubbles. That's just the oxygen in there. And I'm not going to drink this, even though a good amount of this is just water. I'm not going to drink it just because it's never a good idea to drink anything in my class, the things that we make in here. All right. Not all of the potassium permanganate reacted. There is still some potassium permanganate in there. There is still some hydrogen peroxide in there, I'm sure. We don't want to drink that stuff. Okay, so that's hydrogen peroxide. Just a key thing to remember, and it's going to be really important to remember as we get into elephant toothpaste, is hydrogen peroxide, it naturally decomposes, and we can add a few things to speed up that decomposition. That's exactly what we saw here. Alrighty, thanks guys.